get that recording going, like I said, and then we're going to share my screen, and we'll get that PowerPoint up. We'll start talking about the HMH7 SEER product. And so, Randy, as usual, I want you to kind of be my scribe to make sure everybody can see the screen okay, and then we'll just get going from there. Okay, so how's that main screen look, Randy? Does that look okay?
Looks good, Joel.
All right, fellas. Well, thanks again for the opportunity to train with you this afternoon. We're going to be talking about the HMH7 SEER heat pump, and we're going to be digging into literally every wire and every configuration that we can, from the thermostat to the indoor unit to the outdoor unit. And this training is going to take about 45 minutes, so bear with me, but there's some important stuff we want to make sure that we cover. And again, ask those good questions. Please don't be shy. If you got a good question, ask those questions, or hit the chat box up there on the top of your toolbar, and Randy can read that chat box. He's monitoring that as well so that we can answer those good questions for you. So the first thing I always like to remind everybody, even though the HMH7 is not a mini split, let me stress that one more time. It is not a mini split. It kind of looks like one. But you're going to hook it up just like you would a normal heat pump as far as your line set. It takes a conventional air handler or coil inside with just a conventional expansion valve. So again, even though it kind of looks like a mini split, it is not a mini split. It has a suction line and a liquid line just like any other heat pump. But one thing I would like to remind everybody is please remember the unit service fittings are 5/16, very much like a mini split. And you're going to have an adapter that's going to go from 5/16 flare down to 1/4 inch flare for the service hoses. And so a lot of your contractors that already do mini splits, this is going to look real familiar to them because this fitting is similar. It's the same type of service fitting for a mini split. And they probably have these adapters on their truck. But if not, there's a lot of different companies that make them, Robinair, Yellow Jacket, and so on. They'll make these, and you're probably very familiar with them. As a matter of fact, you guys probably have some in your showroom right now that go from 5/16 female down to 1/4 inch male for the service hoses. So you will need that adapter to get your service hoses, onto your gauges. The other thing that we get asked quite a bit, and I thought I'd just throw this little text field up. This is right out of the install guide. And what it is, it's some outdoor coil temperature and indoor coil temperature minimums and maximums. And you can see that, from the cooling mode of operation, dry bulb cooling, the minimum temperature outside is going to be 35 degrees. So right from the factory, 35-degree cooling, -5 heating on the outdoor coil. On the indoor coil, wet bulb cooling is 57 minimum and 50 for heat. And then you look at the outdoor temperature maximum for temperatures, which you guys probably would never see 122 degrees in your area, but who knows? Maybe one day you would with global warming and all that kind of stuff, I guess. But the maximum temperature is 122 and 75 for the outdoor coil in heating and cooling. And then the indoor coil, 72 maximum wet bulb on the indoor coil for cooling and 80-degree dry bulb for heating. And so we get asked this question quite a bit, hey, how far down can I cool, without like any kind of low ambient kit? And the answer is 35 degrees. And likewise, what's the practical point where we want to shut this thing off, where it's not really making that much heat anymore? And that's going to be -5 degrees in the heating mode of operation. So you'll see there's quite a bit of range if you think about it, from -5 in heating all the way up to 122 degrees in cooling maximum temperatures on that outdoor unit. That's a pretty broad range if you think about it. We're talking quite a temperature range there. So they're a very, very versatile unit. They work very, very well. The two pictures of the unit you guys are looking at right now, on the right-hand side, that's the cabinet for the 2 and 3 ton model. And on the left-hand side, that left-hand picture, it's the 2-fan model. The 2-fan model uses the cabinet for the 4 and 5 ton. So that's how they come. They come 2, 3, 4, and 5 ton. Any questions or comments so far?
Nothing here, Joel.
Everybody good?
Yeah, I have a question.
Sure, come on.
So at -5, is that still producing at 100% capacity, or is that a reduced capacity at -5?
That's an excellent question. So basically, our heat pumps are going to be rated, our standard AHRI rating, which is going to be 47 degrees, there's actually two rating points, 47 degrees and 17 degrees. So at -5, it's going to be at a drastically reduced point. So let's say you have a 3-ton unit at 47 degrees outside is producing, let's say, around 35,000 BTUs of heat. At 17 degrees outside, it's going to be probably around 25, maybe 28, 27, somewhere like that. And -5, it'll be probably down around like 8 or 10 or 12,000 BTUs. So yes, it will be at a reduced capacity as that outdoor coil gets colder and colder. So good. That was an excellent question. Good. Any other good questions or comments? Okay. Well, fellas, the first thing we're going to talk about is hooking this up with an AE air handler. And I'd asked Randy previously if we should cover all the products, and he recommended that we do, because you guys are subject to sell some air handlers or furnaces and so on. And so we're going to go ahead and talk about all the different products that this thing will match up with. It's probably one of the most versatile products we have in our entire inventory. I mean, this thing will match up literally with any indoor product that we have, with the exception of the unit that's got the electronic expansion valve. Like for the Momentum 20 and 21 SEER product, that fully communicating system. Because guys, I want you to remember something. This unit, even though it's got modulating capability outside, it uses a standard air handler inside and a conventional 24-volt wiring schematic or scheme, a 24-volt wiring scheme. So it's very, very easy to hook up. Uses your favorite thermostat, your favorite heat pump thermostat on the wall. It's just a great, great product. But then you have all the comfort and all the benefits of the energy efficiency, as well as the comfort of a fully modulating unit outside. So what we're going to be doing, we're going to be discussing the low voltage wiring and setup of the HMH7. And we're going to start out with the AE air handler, which is going to feature a standard high efficiency or ECM motor. Now, some of the key points, that low voltage wiring with an AE air handler, we're going to be using a simplified block wiring diagram. And we're going to literally be talking about it wire for wire. And I want you guys to remember now, on the AE air handler and the variable speed air handler, we've got pigtails. We've got pigtails. We don't have hard screw terminals like we do on the furnace product. We're also going to talk about the wiring of a single pole double throw relay in the indoor unit and how it's used for airflow reduction. So we're going to let the outdoor unit make some intelligent decisions on when to reduce airflow inside, and we're going to talk about how you wire all that up. Now, kit number HMH7AK001 is going to be recommended for convenience and all the supplied parts. So in that 001 kit, what you're going to find a relay, you're going to find some convenience little wiring, not really harness, but just pre-made wires, and you're going to also find a bi-flow filter dryer. And so you guys could pull all this together, with aftermarket parts, but we're going to recommend for convenience and supplied parts just to utilize the kits if those are available to you and if you can get those quickly. So the 001 kit is recommended. Now, it should be noted the HMH7AK002 relay kit can also be used, but that kit is specifically designed to really be used on the variable speed product. But I want you guys to burn this in your brain, if you would, please. The 002 kit, even though it's for the variable speed product, can be used on the other products as well. So if I was going to just buy one kit, the 002 kit, it's like about $10 more expensive than the 001 kit. But I'd like you to consider the 002 kit as a universal kit that works on anything. But the 002 kit, you have to have it for the variable speed products. Whereas on the non-variable speed products, the 001 kit will work fine. Now, it should be noted, if you do use the 002 kit on a non-variable speed product, you just won't use the RV relay for that application. The other thing I want everybody to please remember, that any heat pump thermostat that you select has got to have the BO selection for reversing valve operation. Now, every one of our champion products that we have, with the exception of this product we're going to be talking about, utilizes the O terminal to energize the reversing valve in the cooling mode of operation. Let me say that one more time. All of our other champion products, we energize the O terminal on the heat pump for cooling operation. This product here, the HMH7, utilizes the B terminal to energize the reversing valve in the heating mode. Now, guys, it's not bad. It's just different. We need to remember that, though. We have to select a heat pump that has that BO selection, because what we're going to do on this product here, we're going to energize the reversing valve in the heating mode. So any questions or comments so far before we get into some of those diagrams and talking about wiring these things up literally wire for wire?
PFT fails. If the reversing valve fails, it fails the heating mode.
I like the way you think. No, in this example, on this product, if the reversing valve failed, or let's say you lost that B terminal, it would default into cooling mode. Good question. Good question. So basically, if you energize in the heating mode of operation and you lose that, what's going to happen? It'll switch back to cooling mode. So the default is cooling mode on this product if you lose that B signal. Good question. Any other good questions or comments? Oh, and by the way, while I'm on that line of thinking, to kind of close the loop on that question, on all of our other Champion heat pumps, if you lose the O signal, ooh, it goes into the heating mode. So the default is heating mode on the other product. If you lose the O signal, it'll go to heating mode. And on this product, if you lose the B signal, it defaults to cooling mode. So excellent question. Any other good questions along that line of thinking?
Thanks. I was not aware of that on the other product.
Yeah. So on all of our other Champion heat pump products, every other one, including commercial, we energize the reversing valve O terminal in the cooling mode of operation. This product here, we energize the heating mode, we energize the B terminal, and energize the reversing valve in the heating mode. So there's the difference between it. So like I said, it's not bad, it's just different, and we need to be aware of it when we sell the product, talk about the product, and most importantly, when we apply what heat pump thermostat we're going to put on the wall, to make sure that it has that selection for B and O, so that we can select how we're going to energize that reversing valve for heating or cooling at the thermostat level. So good questions and comments. Any others real quick before we continue? Everybody good?
We're good.
Okay, guys. Dig in and talk about how to wire this thing up wire for wire. Now, please remember, on the air handler products, you're going to actually have pigtails, and I'm showing like a W2, W1C, and all that with a little block. But just remember, that's actually going to be a pigtail on the air handler. But for convenience of the PowerPoint, it's easier just to show like a terminal, even though it's a wire. It's easier to show that terminal. So please bear with me a little bit on that, as we remember that on the air handler products, they're actually pigtails, and on the furnace product, they're actually screw terminals on the indoor product. So starting out with that heat pump thermostat outside, we're going to take that B terminal and we're going to take it straight outside to the outdoor unit. Now remember, we're going to energize that B for reversing valve operation in the heating mode, and that thermostat has to have that BO selection in order for us to do that. W2, we're featuring a two-stage heat strip in our examples. So W2 from the thermostat goes to W2 wire on the heat strip or on the indoor air handler. W1 is going to go from W1 on the thermostat to W1 inside, and then W outside. Now this is important because this first stage auxiliary heat is going to be energized from the thermostat. But guys, please make a note of this. Make a mental note or write this down. It'll also be energized during defrost. So when the outdoor unit goes into defrost, excuse me, it's going to demand that first stage of auxiliary heat. Because remember, guys, when we go into defrost on a heat pump, what we're actually doing, we're putting it in cooling mode of operation. So now the indoor coil becomes an evaporator or cooling coil in the cooling mode during defrost. So we don't want to freeze the homeowner out during defrost. So we have to bring on some auxiliary heat to temper that air, to keep the air from being cold inside when we go into defrost. So just please remember that W1 is going to go from the thermostat to the indoor unit and carry that outside so that we can energize that first stage of auxiliary heat during defrost. Y terminal. Now this is really cool. If you look at it, we're just using a heat pump thermostat with just a single Y terminal. And so we're really wiring the outdoor unit like a single stage heat pump, even though it's got all that modulating capacity out there. It's really cool. So Y terminal is our compressor call, and we'll take that Y terminal outside. We're going to see on our relay a little bit later on, we'll make another connection on the indoor unit, but that Y goes from the thermostat to the outdoor unit. And you're going to please note something also. There may be a factory yellow wire on the AE air handler. If there is a factory yellow wire on the ECM motor, go ahead and take that off the motor. And because we're going to use some function on that motor here in a little bit, you'll see why we did that. The common terminal on the heat pump thermostat is going to go to common, which is normally a blue wire inside. So common will go to common on the indoor unit and then go outside to the common terminal outside. Now, guys, watch this. This is really, really important. We do not take the R terminal outside because the outdoor unit, it's got some functionality out there where it does not need the 24-volt hot from the transformer going outside. So watch this. We just take our 24-volt hot from the thermostat to the indoor unit. We do not take it outside. We don't need it outside. So that's kind of cool. One less wire going outside. G terminal, which is our fan call, from the thermostat goes to G, with typically a green wire, and that goes to the air handler inside to bring the fan on. Any questions or comments so far on this wiring scheme or schematic, if you will, or this wiring scheme so far?
No, but as I'm looking at this, you're basically telling me all I need to have the contractor run is 4 wires outside.
We're not done yet. We're going to have one more wire that we have to bring in from S1. We're going to talk about that here shortly.
Okay.
So basically, he's going to have 5 wires going outside in this configuration, and then he'll have enough wires from the thermostat to the indoor unit to energize however many stages of heat strip he has and so on. But we will have one more wire coming in from outside. We'll show you that in a minute.
So 7 from the thermostat to the air handler and 5 from the outdoor unit to the
1, 2, 3, 4, 5, 7 from the thermostat in. 1, 2, 3, 5 going outside. That is correct.
Okay.
Good, excellent. That was an excellent question. Good question. So as we kind of look at the diagram, we also see that as we were talking a little bit about it, we're going to take a wire from S1 outside, S1, which is an output from the outdoor unit to energize a relay inside. Now this relay in this example is going to be that 001 relay. Or if you just had a generic single pole double throw 24-volt coil relay, you could use that as well. And I want you guys to really study this configuration. It's just a simple single pole double throw relay. Now we encourage you to use our kit because you got everything in that kit. You've got a biflow filter dryer, you got a relay, you got some wires to kind of help make it up and all that stuff. But a contractor could take just a generic peanut relay and wire it up like we're showing you here, as long as it's got a 24-volt coil and single pole double throw switching action. Mount that inside and then put his own biflow filter dryer on and then just make up his own field wiring. So I don't want you guys to think that you're stuck if you don't have the 001 kit, because you can just use a generic relay inside and then the contractor can put his own biflow filter dryer on the liquid line that he probably has on his truck anyway. So the kit's recommended, but you don't have to have it to make this work. As you see, it's just a simple, generic 24-volt coil, single pole, double throw switching relay. So S1 from outside comes over and hits one side of that relay coil. The other side of that relay coil goes up to common terminal. So you're just going to make it up inside the air handler so you can energize that coil from that S1 output outside. Any questions so far? Everybody good?
Good.
Okay, now what we're going to do, we're going to take the common terminal of the switching contacts on the relay, common of the switching contacts. We're going to tie it into yellow going outside for a compressor call. So basically, anytime the compressor is calling, we're going to have power. Anytime the heat pump's calling for compressor operation, we'll have power on that C terminal, that common terminal of the switching contacts on the relay. On the ECM motor itself, we're going to take a wire from the ECM motor on high-speed tap, and we're going to go up and we're going to tie it on to W1. So basically, anytime we get a W call, an auxiliary heat call, or a defrost call, we're going to go ahead and energize that ECM motor on high-speed airflow. Now, that's very, very typical. Now, the contractor can change that if he wants to, but you're going to find that this is a typical operation, so that if you do have an auxiliary heat call, you're going to go ahead and drive that motor to high speed. That way you don't overheat the heat strips and all that. So if you have an auxiliary heat call, remember that ECM motor is going to be driven to high speed via that high speed tap and that wire that we're hooking on to W1. Now, the normally closed contact on the switching relay, one more time, the normally closed contact on the switching relay, we're going to take a wire over to the ECM motor to provide 100% cooling airflow. So when the contractor is hooking these things up, he's going to have to select a speed tap to give him 400 CFM per ton of cooling. And so just as a quick reminder, we always want to design our ductwork, and we always want to set our airflow up so that we have 400 CFM per ton. So here's an example. If I got a 3-ton unit setting outside, I need 1,200 CFM for 100% cooling airflow. If I got a 2-ton unit setting outside, I need 800 CFM for my 100% cooling airflow. So it's important that, you know, the contractor set his airflow up and all to make sure that he's getting 100% airflow when that on the normally closed contact of that relay. The normally open contact on the relay, we're going to go over and we're going to select a speed tap that's going to give us about 60 to 65% airflow. So that when that relay switches, what's going to happen, it's going to reduce the airflow to about 60%. And so this is how this works. Basically, what happens is the outdoor unit makes intelligent decisions on capacity. And when it gets down to a certain capacity, about 50 to 60%, it's going to generate an S1 signal, switch the relay, and slow the airflow inside to properly match the point of modulation or capacity outside. So this thing really gives you some phenomenal comfort because the outdoor unit's making intelligent decisions on when to reduce airflow inside. So that normally open contact on that relay, we're going to go over to the ECM motor and we're going to select a speed tap that's going to give us about 60 to 65% airflow. Any questions or comments so far before we do some little animations and kind of show you how this airflow reduction works? But let's make sure everybody's squared away on what we're looking at right now before we continue. Any questions or comments?
We're good here, Joel.
Everybody good? All right, fellas. So basically, we've wired this thing up, and now let's talk a little bit about some functionality. So let me do that animation again. So if the outdoor unit says, hey, I need reduced capacity, I'm in reduced capacity and I need reduced airflow, it's going to energize S1, the terminal S1 outside, and it'll send a 24-volt signal to the relay. The relay will then switch. Let me show you that animation one more time. S1 is energized outside for reduced airflow. The relay switches, and now we're commanding about 60 to 65% airflow on the indoor coil. And so the outdoor unit is, again, making intelligent decisions with that S1 input for reduced airflow outside. And it makes that S1 input outside and it sends it in on that fifth wire that we were asking about earlier, energizes that relay and reduces the airflow inside. And so that's one of the reasons this thing is such a humidity-eaten machine, is because the outdoor unit, when it sees it's got some reduced capacity going on, it's going to lower the airflow inside and allow the unit to continue to run at a reduced capacity and a very, very high comfort level as it continues to eat that humidity, especially in humid environments. Any questions or comments before we talk about one or two other little functions so far? Any other questions or comments?
Nothing.
Everybody good? All right, so fellas, so one thing that's going to note that I want everybody to note that if we should have an auxiliary heat call, and there's if the thermostat calls for W1, or if the outdoor unit goes into defrost, what's going to happen, we're going to generate a W1 call. And even though the ECM motor might be at a lower speed right now, if we get an additional W1 call on the indoor high efficiency motor, it's going to go ahead and drive it to high speed, and basically it will ignore that S1. So I want everybody to catch that. So if we have an auxiliary heat call, we're always going to drive that indoor motor to high speed to make sure we don't overheat the heat strips and stuff like that. And please remember one more time, any W1 call will be present with the thermostat auxiliary heat call or during the defrost cycle. So just please remember, if the contractor says, hey man, every time this thing goes into defrost, it speeds the fan up. There's nothing I can do about it. That's correct. That's exactly what it's supposed to do. Any questions or comments on how we're wiring up the AE air handler before we move on to some other products and talk about the specifics of some other products?
Looks good here, Joel.
Everybody good?
I'm good.
Okay. Fellas, the next thing we're going to talk about is standard ECM furnace products. Now, it's going to look very, very similar to what we just did, but please remember that the TME and the TMY furnaces are standard ECM motors, high efficiency motors, but they're not variable speed, but they are high efficiency motors. And we're going to dig into that low voltage wiring again with those two products and look at some simplified block wiring diagrams just like we did before. Now, please remember the TME furnace, the TME is a single stage furnace and the TMY is a two-stage furnace. We're going to continue to use that single pole double throw relay in the indoor unit. We're going to talk about how it's going to be used for airflow reduction just like we did before. Please remember that that 002 relay kit may be used. However, one of the relays will not be needed for this application. Finally, on the heat pump thermostat, you still have to have that BO selection for reversing valve operation, even on a furnace product. And please remember, you also have to have a heat pump thermostat with dual fuel function when you're going to use it with the furnace product. So let me say that one more time. The heat pump has to have the capability of energizing the reversing valve B in the heating mode. And we also have to have a thermostat that's going to have dual fuel capability because we're allowing the thermostat to determine when we're going to switch over from heat pump to gas furnace. So make sure that that heat pump thermostat has dual fuel function. And quite frankly, any of your, upper end Honeywell, White Rogers, Robert Shaw, whatever heat pump thermostats are going to have that capability of dual fuel operation as well. So just keep that in mind, though. On the furnace, you have to have a dual fuel capable thermostat. As we take a look at this, you're going to notice, hey, this looks pretty similar to what we just did on the AE air handler because it is very similar. It's the thing we got to remember though is that on the furnace, a couple things is you're going to have hard screw terminals instead of pigtail wiring, and you have to have that dual fuel thermostat on the furnace. But other than that, guys, that B terminal from the thermostat is going to go straight outside just like it did before. And we're going to energize that reversing valve in the heating mode of operation. And because we just have the TME is a single stage furnace, we're just going to have W1, or W1 from the heat pump thermostat to W on the furnace. And because it's just single stage, we're only going to have that single W terminal. And then that'll go outside as well to tie in the outdoor unit on W to bring the indoor unit on during defrost or during auxiliary heat call. Now, fellas, just like we had before, that Y is going to go straight outside like we did before. Our Y is our compressor call from the thermostat to the outdoor unit. And guys, I want you to think about this too when you're talking to your customers about this. This HMH7, even though it's got all this comfort and all this capability, it wires so easily. You've got 5 wires going outside. Really, you wire the thing about like a single stage heat pump. It's very, very simple with all that capacity. 24 volt common, that C 24 volt common is going to go from the thermostat to the indoor unit to the outdoor unit. That's very, very conventional, just like we had before. And fellas, please remember the R terminal, that 24 volt hot, goes from the thermostat to the indoor unit. We do not carry our 24 volt hot all the way outside. We don't have to have it outside with this wiring scheme and with this product. G remains our fan call. G is our fan call. And just like we had before, we're going to have S1 is going to be tied into one side of our relay coil for that airflow reduction from the outdoor unit. So again, if you count them up, 1, 2, 3, 4, 5 wires on the outdoor coil. On this product here, we're going to do the same thing. We're going to take the other side of the relay coil and go up and tie it onto common on the indoor product. So we can energize that relay or have that circuit for that relay coil. Common on the switching contacts of the relay will still go to yellow or Y, just like we had before. Now, because the furnace actually has terminals on it, for first and second stage cooling, we're going to take that normally closed contact on the relay and take it to Y/Y2. That's how that terminal is actually designated on the furnace as Y/Y2. We're going to take the normally open contact on the relay and go up to Y1. Again, that's our first stage airflow. Now, fellas, I want you guys to look at something, and you may not have been aware of this, but this is one of the reasons I love to do this training, is because the TME single stage furnace, let me say it one more time, the TME model of our single stage furnace, that would be like a TM9E or a TM8E, either one. Even though they're single stage heating, a lot of folks don't realize that they're two-stage cooling capable. And so let me say that again, the TME single stage heating furnace is actually two-stage cooling capable, or you can reduce the airflow on the thing. So that's a real sweet little combination if you think about it. You know, a TME furnace, a TM9 or TM8E furnace is a nice entry-level furnace, but it will work perfectly well with our HMH7 outside, and because it has the capability of two stages of cooling airflow. Isn't that the coolest thing? No pun intended. Any questions or comments on how we've wired this up? It should look very similar to what we just did on the other air handler, because it is. It's just that now we're dealing with a furnace product, and you'll notice that the terminals are a little bit different, labeled a little bit differently on the furnace product. Any questions or comments on how we wired this up before we talk about a two-stage furnace?
Corey, you guys are primarily going to be utilizing furnaces versus heat pumps, correct? Or versus air handlers?
I would say that's probably going to be 80% or somewhere.
Okay. Let me ask you cats a question real quick then. Of your furnace products that you sell the most of, do you sell a lot of the TME or the TMY or the variable speed? What furnaces do you sell the most of?
The TME, and then I think the 95% would probably be actually, I think we sell more 95s than we do TMEs.
Okay.
Did you, have you guys checked for any rebates in your market for heat pumps?
So there are rebates. I actually have a note of my things to do. One of them was to call Kansas City Power and Light or Evergy and find out what the rebate plan was.
Cool.
For the area, because I used to know it when I was a contractor, but I'm not up to speed on what the current plan is now.
Okay. Yeah, because there's we can get some really high levels of efficiency out of these units with variable speed products.
Yeah.
So
I think it's somewhere around $500, somewhere between $500 and $600 for a 3-ton that's coming in 16 SEER or north of that.
That's huge.
That's nice. That's nice. Let me ask you guys another quick question, just a little checking question. Did everybody on this call know that the single stage furnace, the TM9 or the TM8E, either one, the single stage furnace, did everybody know it has two-stage cooling capability?
I'll be honest, I didn't know that.
Yeah, isn't that neat though, that you could take your entry-level furnace or a variable speed furnace or a two-stage furnace, and they're all compatible with this HMH7 outside. I mean, it's just a great product.
That's very cool.
Yeah, I thought so too. Well, fellas, let's talk about the TMY furnace, which is basically a two-stage furnace. And guys, it's going to wire exactly the same as we just did on the single-stage furnace, as far as the relay and the fan motor and the Y1 and Y2, it wires exactly the same. So instead of going through all of that, let's just talk about the differences. The only difference is the TMY is a two-stage furnace, so it's going to have a W2 call or a W2 terminal, and it's also going to have a W/W1 terminal. So the only difference between what we just did and this furnace is the fact that we're going to have a W2 for second stage heat on this furnace. So we'll have to make sure and have a W2 from the thermostat to W2 on the furnace, and then a W1 from the thermostat will tie onto the W/W1 terminal on the furnace, and then it goes outside to W outside, again, for the purposes of auxiliary heat, first stage auxiliary heat, and also during defrost. So that's the only difference right there, is you'll have an extra wire. If you want to have a TMY model of furnace, either a TM9Y or TM8Y, we have matchups on AHRI for both of them. So this gives you some real nice flexibility for two stages of heat, and then 2 stages of cooling as well, you know, from a thermostat standpoint and from a relay standpoint. But the outdoor unit, remember guys, the outdoor unit is actually modulating from about 35 or 30% up to 100%. And then it's going to reduce airflow inside based on its point of modulation. So it's a very, very high-end piece of equipment outside using a simple indoor unit and a very simple heat pump thermostat, which is pretty cool. Now, guys, please remember also, if you're hooking it up to a furnace, you got to have a heat pump that's dual fuel capable. Just, I know I've stressed that several times, but it's really important that we remember that. Now let's take a look at let me do some animations here. So on the TME and the TMY furnaces, when we have that S1 input from the outdoor unit, we're going to switch that relay and we're going to go to reduced airflow on that Y1 terminal. And so please notice that it switches that relay. Let me do the animation one more time for you. We're going to switch that relay when we get an S1 input from outdoor unit. We're going to switch that relay and reduce the airflow. So the obvious question becomes then, what is my default? If S1 is not energized, what's my default? Well, it's 100% airflow. And then when the outdoor unit makes intelligent decisions on when to reduce the capacity of the outdoor unit, it's also going to send that S1 signal inside to tell the indoor unit, hey, we need to go down to 60% airflow because we have reduced capacity outside. Any questions or comments before we jump into some variable speed products for you and talk a little bit about some airflow considerations, then we'll wrap up the training shortly after that. Any questions or comments so far?
We're good, Joel.
Everybody good? Okay. All right, fellas, as promised, the next thing we're going to talk about the low voltage wiring and setup with the heat pump with a variable speed air handler and a variable speed furnace. This low voltage wiring with variable speed is going to be a little bit different than what we've talked about because we're going to have to use a different relay kit. We're going to be using the 002 relay kit. You have to use the 002 relay kit or 2 separate switching relays, which we'll talk about. Now, please note that the terminals that are not going to be used for the HMH7 outdoor function, we're not going to cover those or talk about that for simplicity. Some examples would be like the HUME terminal or the DHUME terminal or the electronic air cleaner terminal. That all has to do with inside, and that's a separate class. I mean, if you guys want to dig into a variable speed air handler and variable speed furnace, you know, we can cover all those terminals, including the electronic air cleaner terminals and stuff. But because it has nothing to do with this outdoor product and how you wire it, we're just going to skip those today for the purposes of simplicity. Now, please remember, again, one more time, that wiring accessory of the relay kit HMH7AK002 is required. Now, this kit comes with 2 relays on it, mounted on a board, and they're going to be designated RV and S1 for the 2 relays. And again, we're going to just recommend this kit for convenience and supplied parts, with the exception or with the qualifier that if you don't have this kit, you can still sell your contractor 2 just generic relays. Some examples would be, for instance, you guys probably have them on hand, you know, those little White Rogers 90 370 relays, you know, those little peanut switching relays that cost about 10 or 15 bucks. You can literally use those relays instead of what we're showing you in the kit if you have to. And then the contractor could provide his own bi-flow filter dryer if he wanted to. So you don't have to use the kit. We just recommend it for convenience and the supplied parts. Now, guys, please remember that BO selection is going to be for reversing valve operation. That stays the same. And a heat pump thermostat with dual fuel function if you're going to be hooking it up to a furnace product, as another quick reminder. So let's go ahead and jump in this. So we see right now, in this example, we have an AVC air handler, just a standard variable speed air handler with a 2-stage heat strip. And please remember now, we're going to have to use that 002 kit because it has 2 relays at the bottom there. You can see 2 relays down there. And we've kind of made it simple to look at because those relays are actually mounted on a board, but we kind of spread them out so we could talk about the wires and stuff like that for simplicity of training today. So let's start at the heat pump thermostat on the left. We'll see that B terminal goes all the way through just like it did before to energize that reversing valve in the heating mode of operation. W2 from the thermostat, we're going to carry a wire in We're going to hook it up to the W2 terminal, which again, on the air handler, you're going to have pigtails. So you're going to have that's typically, I think, a brown wire or kind of a light brown wire. That's why we show it there. And then W1 will be our first stage auxiliary heat. And that'll carry all the way through to the outdoor unit, just like we did before. You guys are going to notice this looks very, very similar because most of the wiring is going to be the same going outside, just like we had before. That Y terminal goes straight outside again. We'll make some connections in the air handler, but you're going to have that yellow wire going straight outside. That's your compressor call. C is our 24-volt common. It's going to do the same that we did before and take it straight outside. R terminal is going to go from the thermostat to the indoor unit. Same way with the G terminal. Now, one of the things you guys are going to be pretty impressed with, I think, it doesn't matter even if you're on a variable speed air handler or a variable speed furnace, you still got those 5 wires outside. Isn't that the coolest thing? You know, even though the variable speed stuff has got more functionality, we're gonna keep most of that low voltage wiring inside the cabinet inside. You still only have those 5 wires going outside, and I think that's pretty cool. So on the indoor unit, we're going to connect both sides of both relay coils to common. So we're just showing that right now. We're going to just connect them both to common. That way we can have both sides of those relay coil circuits completed to common. Now on the S1 relay, the relay on the right-hand side, we're going to take that S1 wire. We're going to come down. We're going to hit the other side of that S1 relay coil. And again, count the wires outside. 1, 2, 3, 4, 5. You got 5 wires going outside, even on a top-end variable speed product. And I think that's just really cool. On the indoor unit, we're going to take the common terminal on the 1S1 relay, and we're going to take it up to up to Y like we did before, so that anytime you have a compressor call, we have 24 volts on the switching contact, the common of the switching contacts on that first relay. We're going to take the normally closed contacts on that relay, that S1 relay on the right-hand side there, that normally closed. We're going to go up and hit Y/Y2 for our second stage airflow. Normally open contact on that first relay is going to go to Y1, just like we had before on our 2-stage cooling capable products. That relay wires up exactly the same. This looks real familiar to you because we just did it on those other products that had the 2-stage cooling capability. Any questions or comments so far? Everybody good?
We're good.
Now watch this. On the variable speed product, whether it's an air handler or a variable speed furnace, what we're going to do, we're going to take the other side of the relay coil, we're going to take it up to the B terminal. So here's the idea. Anytime the heat pump thermostat calls for heating mode of operation, and we energize the B terminal to energize the reversing valve in heating mode, we're also going to energize that RV relay on the left-hand side. Now watch this, that RV relay on the left-hand side, we're going to take 24 volts on the terminal, the switching common terminal, just like we did on the other relay, from Y down to C. And the normally closed on that other relay, that RV relay, goes to O terminal. Now you guys are looking at this and saying, well, that's just crazy. Why do we have to have that relay on that O terminal only? Here's the answer. Because on the variable speed air handler or the variable speed furnace, any of our variable speed product, in other words, it has to see an O signal on the O terminal on a heat pump. On a heat pump application, it has to see O terminal energized in the cooling mode. And so anytime it's on a heat pump and it's set up for heat pump operation, it's looking for an O signal in the cooling mode of operation on the indoor unit for advanced functions of dehumidification and some other functions, and ramping operation in the cooling mode. So for advanced functions, it has to see that O signal on a heat pump application on the indoor unit. So that second relay, the only reason it's there is so that when we're in the cooling mode of operation, we energize the O terminal. Any questions or comments on that? Everybody good?
Everybody's good.
Now we're going to find out a little bit later on when we go into the heating mode by energizing the B terminal on the thermostat. We go into the heating mode of operation. We're going to switch that relay and break that O signal, because in the heating mode, we don't want to see that O signal on the indoor unit in the heating mode, only the cooling mode. Okay. The TM9V or the TM8V two-stage furnace, I want to note something to everybody. It wires exactly like the air handler. It's just that the only difference is between the two screens, you'll see that there's pigtails on the air handler, and the terminals are a little bit different on the furnace where it says W/W1. So they're hard screw terminals. Other than that, the variable speed two-stage furnace, two-stage heat furnace, two-stage cooling capable furnace, it wires exactly like the variable speed air handler. The only difference is the terminal configuration is labeled a little bit differently, but it wires exactly the same. And those are hard screw terminals on the furnace. Now watch this. Oh yeah, please remember the TME furnace requires a dual fuel thermostat. I guess I've said that enough, but I went ahead and put a little text field there just for everybody to be reminded. Now, when we go to our first animation, let me do it again. When we switch that first relay and the outdoor unit, we're in a situation right now on those variable speed products. So we're running the unit. We happen to be in the cooling mode right now. When we get an S1 output from the outdoor unit, let me do the animation again for you. We're going to switch that first relay for reduced airflow, just like we had before. And so very, very simple. The outdoor unit makes an intelligent decision, generates an S1 output, switches the airflow from Y2 down to Y1 for reduced airflow. Any questions or comments on that? Okay, so now the other thing we're going to be looking at is in the heating mode of operation, the B input. Let me back up the animation one more time. When we go to the heating mode of operation, guys, and the thermostat calls for heating mode of operation, and we energize the B terminal for the reversing valve in heating mode, notice that second relay on the left-hand side. Let me do the animation again for you. We switch that relay on the left-hand side, and what happens is it breaks that O terminal, and so now it's telling the indoor unit, hey, we're hooked up to a heat pump, but we're in the heating mode of operation, and we've broken that O terminal. So that second relay on a variable speed product, the only reason it's there is to break that O signal when we go into the heating mode of operation, because it has to have that functionality for advanced functions on the variable speed product. We have to energize and de-energize that O terminal based on if we're in the heating or the cooling mode of operation. That's the only reason that other relay is there. Any questions or comments on our low voltage wiring schematic and schemes for our HMH7 outdoor unit with all of our different indoor products? Any questions or comments before we talk about some airflow considerations?
No questions come to mind, but very interesting.
Okay. All right, sounds good. Well, again, fellas, we're going to have this out we'll have this recorded out on the YouTube training channel. Randy's going to send you that link after our training session, and you'll be able to go out and look at this as much as you like. Okay, let's talk a little bit about some airflow considerations, guys, as we start kind of winding down our training session this afternoon. Please remember on every install to confirm proper airflow. I just can't say that enough. The HMH7 is a modulating capacity unit, and nominal airflow is absolutely critical. It's a huge thing. We have to have the proper airflow to make this thing work outside. The duct size and the ductwork should be able to provide 400 CFM per ton of total capacity. And so when the contractor builds his duct system, we want to make sure that they build it to a full 400 CFM per ton of capacity outside. Again, if they got a 2-ton unit sitting outside, they need 800 CFM. If it's a 3-ton unit outside, they need 1,200 CFM and so on their ductwork. So it's very, very important. Now, if you get asked why it's so important, here's a really good answer. Because the outdoor unit is modulating. What it's doing, it's got some advanced features out there. It's looking at suction line temperature. It's looking at suction line pressure. It's looking at liquid line temperatures, looking at outdoor temperatures, taking all those temperatures, and it's plotting its capacity. So let's say, for instance, we had lousy airflow inside, the suction line temperature is going to go down as the superheat starts falling, and the outdoor unit will interpret that as a reduction in capacity. So it's going to start screwing back. And so literally on this unit here, if you have poor airflow, you might have a 3-ton unit setting outside, but if you have poor airflow, it may never go beyond about 2.5 tons of capacity, we'll say. So it's important to get the full capacity of the unit and the full modulation of the unit and the 100% capacity when necessary. We've got to design our ductwork to give us the full airflow. So if you get asked some of those good questions, just please remember that of all the units we have in our inventory, with HMH7 and our modulating equipment, airflow becomes very, very critical because it needs proper airflow to modulate properly. Any questions or comments on that before we talk about a couple other considerations?
Joel, in the event you get up to 2 o'clock here, I got to jump 2 o'clock. So.
Okay, yeah, I'm just about done anyway, Randy. That's fine.
Okay, thanks.
Yep. Fellas, again, some things we want to ask that the contractor do is please look at ACM Manual D and the velocity tables. We'll see that, there are some recommended main trunk velocities right in Manual D. So we ask that they please, look at that and make sure that they comply with that. Same with branch ducts and registers and grills and diffusers and so on. And probably one of the very, very most important thing with Manual D airflow is the fact that if you have a filter that's in a grill, in other words, if you've got a filter grill with a filter in it, do not exceed about 300 feet a minute velocity across that filter as an airflow consideration. So fellas, that pretty much concludes our training. Is there any questions or comments or any final questions or comments before we secure for the day on our HMH7 heat pump overview?
Joe, my biggest question. Who's next? Who's up? I'm concerned. I want replacements.
Okay.
Can they just somebody's out bring the replacement heat pump? They can just plug this one in to existing systems.
That's a good question. So if you've got a situation where it's a replacement and you're going to keep the indoor unit, it's important that indoor unit has the capability of having that airflow reduction. Let's say you have a 2-year-old high-end variable speed carrier heat or carrier air handler or whatever. There's no reason you couldn't use it as long as you've got the right airflow and you could wire it up to where you can reduce that airflow. Because that's going to be the huge thing on the HMH7 is the fact that, you want to be able to reduce that airflow, during that reduced capacity.
Okay, so my concern is I've allocated 0 heat pumps this year, standard heat pumps, and I don't know how I get that. I need something to be able to sell people.
Well, and guys, if you get in a situation, where you're going to apply this product and it's a special application, please call me and we'll just walk you through and we'll talk about it and we'll just see if you'll be able to do that. Now, of course, we always recommend, as per our training, you take an HMH7 with a matching indoor coil or air handler or furnace and coil and go accordingly, because our equipment's engineered and designed to work together. But if you do have an oddball situation where you have another brand air handler inside or coil and furnace, just give me a call and we'll walk through it and figure it out together.
Okay.
So if I'm hearing you right, you're telling me that that the homeowner doesn't want to replace the furnace and it's 15 years old and it's a Lennox or some off brand, that there is a possibility it's not going to work and we need to actually have that conversation prior to.
Absolutely. Yeah, we need to have that conversation, because if you don't have the capability of doing an airflow reduction on the indoor unit, then you kind of wasted the capability of the outdoor unit.
Okay, fair.
Good question. Any other good questions or comments before we shove off for today? Well, folks, I'll tell you what, I'm going to go ahead and stop the recording.